My name is Terrence Barkin, and I'm the Executive Director of the Graphene Council. We are hosting today's webinar presented by Dr. Andy Goodwin on First Graphene, one of the leading companies producing, selling, and applying graphene worldwide. The Graphene Council connects more than 30,000 material scientists worldwide who have an interest in researching, producing, and using graphene materials. And these webinars are a way for us to help educate the community about what's happening in this exciting and rapidly developing field. So with that, I want to welcome Andy Goodwin, who's our presenter today. Andy, are you ready to go?
I am, Terrence. Thank you. So thank you for the introduction, and thank you for the opportunity that the Graphene Council has given us to present today. And hello, everyone, and welcome to this this webinar. I'm going to take about 30 minutes to talk through some highlights of what First Graphene are, First Graphene's current status and what we're doing this year, and then as Terrence said, we'll go into a Q&A session. So I'm Andy Goodwin. I'm a non-executive director and senior scientific advisor with First Graphene Limited. I'm based in the team in Manchester, UK. My background is a chemist. I'm a PhD chemist with many years experience in specialty chemicals, and I've been working on graphene materials since 2012. So into the presentation on First Graphene. So we'll start with a question. So what do composites, rubbers, energy storage, and concrete all have in common? And as you all dialed into the Graphene Council, I'm sure you appreciate the answer to this is, of course, graphene. So what we're seeing with graphene is a growing number of these established markets and applications are being significantly enhanced by graphene materials. And those are graphene materials that are typically incorporated into another system, incorporated into another product as a performance enhancing additive. So why is that happening? What makes graphene compelling? Well, in rubbers and elastomers and polymeric materials, we see improvements in tensile strength and elongation, durability with the addition of graphene. And there's now multiple studies that show that when graphene is added to these materials, you get typically 30% improvement in mechanical properties such as resistance to wear. Graphene itself, it's the thinnest material that was ever isolated, which is one of the reasons it caused so much scientific excitement and the Nobel Prize. Despite its thinness, it's stronger than steel on a relative basis, and it is the most electrically conductive material that's known. These properties mean that when you add it to different systems, it can have an amazing effect despite being added at low levels. And a great example of that is in cement-based materials and concretes. So we've shown that as little as 0.01% by weight of graphene added into a concrete can increase the compressive strength of the concrete by more than 30%. Which in turn means that you may be able to use less cement, less concrete materials to build a structure or to successfully complete a project. And that has a significant impact on that industry in terms of CO2 footprint. So that's just one example of where graphene can make an impact. So what about the properties of graphene? Well, our graphene, which I'll talk about in a moment, it has a unique chemical fingerprint, which makes it easy to use. It's very dispersible in a multitude of systems, which includes solvents, resins, elastomers, and different formulations. Once you've added it into those systems, the benefits you can expect are shown on this slide. So you get strength improvements, which in turn can enable lightweighting. It's highly electrical and thermally conductive, and it enhances barrier properties. So it can improve properties such as corrosion resistance, fire retardancy, water repellency, and extend life and durability. The next slide is an overview of First Graphene, and I'm not going to read through all of this because it's a very detailed slide, but this is something you can look at after the presentation, and it's really a statement of current status of the First Graphene business. So some highlights from here. So we're an Australian-based company. We have our major manufacturing site is in Henderson, which is Western Australia. In the UK, we are a tier 1 partner at the Graphene Engineering and Innovation Centre, which is in Manchester. And we've been an active participant in getting graphene registered as a new substance in different regions around the world. What I would highlight on this slide is what we do. We produce a high-performing graphene product, which we've branded PureGraph, and we are the acknowledged quality leader in graphene materials. And we've been getting excellent feedback from our customers in terms of product quality and repeatability. We have a built 100-ton capacity to manufacture these materials. The plant itself, which I'll talk about in a moment, it's relatively low capital costs, and we're currently looking at where we would locate our next manufacturing facility. We've got 5 core market sectors where we're actively working with customers, and these are rubbers and elastomers, cement and concretes, composites and plastics, coatings, and energy storage. And I'll give more detail on those later. If you look at our current status and our forward looking plans and outlook, we consider that we've now established a supply position for high quality graphenes. We have an excellent product base with the PureGraph range of products. And we really consider that supply side as banked for the current stage of the graphene industry. And we're now strongly focused on commercialization of PureGraph and driving adoption of these materials in downstream products. The supply capability, which we consider to be world leading in the industry, is based upon four strong pillars. The first is we use vein graphite raw materials. So we use very high quality raw materials. These are captive. We have licenses and mines, so we have a secure supply of raw materials. There's no processing occurs at the mine, so this material comes straight from the mine to our factory, and we have significant in-house stock to supply demand. The raw materials themselves are low in metals, and they also enable us to make large graphene platelet products. The second pillar is our proprietary and unique electrochemical exfoliation process. This is a single-step, high-yield process, and it's unique to First Graphene. It's scalable. We've already shown we can scale this. It's low cost, and it has a very low waste footprint. The big advantage with the electrochemical exfoliation over mechanical methods is because it's the platelets are lifted from the graphene platelets are lifted from the graphite raw material by driving ions into the material. It lifts off very large, very thin platelets. So our PureGraph products have a very high aspect ratio, which is the lateral size divided by the thickness, which means they're very high performing products. Following exfoliation, we've got a very well established industrial finishing processes. These use industry standard tools and techniques, so they're very easy to scale, and they enable us to control the quality of our product in terms of platelet dimensions, platelet functionality, and also dryness of the final product, which gives us a range of finishing options at our factory. All of these are scalable, they're relatively low cost, and again, the waste footprint is very low. And lastly, and very importantly, we have a really strong focus on quality assurance. As a specialty chemicals business, we completely understand the importance of repeatability and consistency of raw material supply to our customers. No customer wants to invest the time in developing a formulation in 1 year and then find out 12 months later that the raw materials changed and they've got to reevaluate their formulation. So we've put much effort into controlling the quality of our process. So we use a Six Sigma approach. We monitor the behavior of our processes. We've developed our own industry-leading measurement techniques, which are well aligned with ISO TC 229, and some of those have been published. We use regular at-line testing in our factory, and every batch of product that's shipped has its own certificate of analysis with it, so our customers get assurance of the quality of the product. The Puregraph product that we manufacture, it's a really interesting material because it is high aspect ratio, thin platelets, and we allow a small amount of oxidation at the platelet edges, which means that the platelets are easily dispersed and available for functionalization also. So we believe it's the highest performing graphene additive that you can buy in tonnage quantities. As I said, it's a pristine high aspect ratio platelet. There's some data shown on this slide. So the top slide, the top image is scanning electron microscopy, which is 100% of the powder just simply placed into an SEM. And you can see these high aspect platelets distributed through this material. Further analysis by techniques such as Raman, AFM, and TEM shows that the platelets themselves are typically less than 10 carbon atoms. Recent work that has just been published by the University of Adelaide, which is a central image on this slide, shows that by doing edge analysis, they calculated that the average platelet thickness in our Puregraph 5 was 6 carbon layers. The other parameter which we can carefully control is the lateral size. And the reason we do this is, again, to protect our formulating downstream customers. It's really important that there's no drift in the oversized materials in these raw additives. So the image you see at the bottom right is a particle size distribution of one of our products. And you can see on the high side, it has a very well controlled cutoff. So there's no oversized materials in here, which give formulators, plastic compounders, all kinds of issues if they're present. So this is something that our customers really like about the Puregraph products. We also continue to innovate in the Puregraph product line, and recently we've released a water dispersed Puregraph product, which we call Puregraph Aqua. And this is actually a graphene hydrogel. And the reason for releasing this is it's easier to use in polar and water-based formulations, such as coatings, cement, and rubbers. And we've got multiple customers evaluating those materials right now. Of course, we continue to look at product development, and we continue to look at the needs of our customers. And we are developing ways to further control platelet sizes and functionality, which will aid the use and application and extend into new applications and markets for Puregraph materials. Our leadership team, I'm not going to talk through the detail of this slide, but I just wanted to highlight some recent changes we made in the leadership team. So earlier in 2021, we appointed Michael Bell as a new Chief Executive Officer. Mike has got 20 years experience in high growth industries, and he's joined the team, and he's really strongly focused on growing the sales and growing the business. So he's been with us since early 2021. We also appointed a new Chief Financial Officer, which is Adi Astana. And again, you can see he's got multiple years of experience in different kinds of businesses based in Australia and Asia. And then finally, we have a new non-executive director, which is Michael Quinnett. And Michael's a very experienced corporate lawyer and brings really fantastic knowledge of corporate governance in Australia. And it's been a great addition to the team. With Mike Bell joining as CEO, it's really up to our game on the commercial side. And we're starting to focus on these 5 market segments in much more detail. And as I said earlier, the 5 market segments that are of particular interest to First Graphene are the ones shown here. So that's rubbers and elastomers, composites and plastics, cement and concrete, coatings, and energy storage. And more on those later on in the presentation. Alongside that, we do continue to look at innovative solutions. We do understand this is graphene's a new market, and we need to keep our eye on emerging trends. So we continue to look at alternative routes to graphene and graphene-like materials. So we have developed a novel cavitation process. We've licensed, I should say, a novel cavitation process, which enables us to make graphite and graphene materials directly from petroleum feedstocks. And we're looking at this as a route to make graphite in particular for battery as a battery material. The only byproduct from the process is hydrogen. And I'll talk a little bit more in detail about that process later on. We continue to support customer application development in polymer strengthening and wear resistance. And we've got multiple qualifying trials in composites and concrete. We've also continued to engage with battery materials and alternative energy materials. So we've continued to progress technologies in supercapacitor and particularly catalysts for hydrogen fuel cells. So to come back to the emphasis on the commercial side of the business, so Mike has appointed 3 commercial managers to lead the segments, 3 of the segments that we're interested in. And we're also actively recruiting through 2021 for rubbers and elastomers, energy storage, and the coatings sectors. So let's have a look at some of those sales and growth sectors in some more detail. So rubbers and elastomers. So what's the advantage of using PureGraph in these systems? Well, firstly, of course, we've got robust supply and dependable quality position, which means we can interact with customers in these sectors. In rubbers, we typically see increased strength, increased durability and wear, increased fire retardancy. And one of the advantages we have with PureGraph is the ease of dispersion. And we now have a latex rubber compatible solution with the PureGraph Aqua. On the right shows that it's a typical performance graph that we see for performance enhancement in rubbers. This particular example is in polyurethane systems that are used for mining wear liners. And I'll talk more specifically about this example in a little while. But simply looking at the chart, this is normalized performance with the blue bars being polyurethane without PureGraph and the green bars being polyurethane with PureGraph. So looking across this chart, you'll see we get significant improvements in tensile strength and tear strength in this elastomer, improvements in elongation, and really significant changes and positive changes in the abrasion performance, which we're now taken through to specific applications. So some of the customers and applications we're working with in rubbers and elastomers. So with Steel Blue, we have an opportunity for Puregraph enhanced footwear. So Steel Blue manufacture specialist safety boots. And they're looking at graphene as an additive in multiple components within the boot to make the boot lighter, more comfortable, improve the grip, and improve the wear resistance. And we've been working with Steel Blue for probably 2 years now, and they will launch a Puregraph enhanced safety boot shortly in 2021, and they're a current sales client. The second example here is NuGen Group. So NuGen are a supplier of wear liner systems to the mining industry in Australia. They've now launched a product range called Armorgraph. Armorgraph is typically a rubber system that includes our Puregraph as a performance enhancer. They've got tier 1 mining companies who are currently evaluating these and moving to adoption, and their interest, of course, is based on reduced cost of ownership. In a recent trial we ran in a real life situation in an iron ore mine in Pilbara, Western Australia, on the reclaimer bucket, which is shown in the image. The trial ran with the buckets for more than 12 months, and they demonstrated an improvement in durability of the wear liner with graphene with a factor of 6. So this means that by using graphene, you can extend the wear life of these products by up to a factor of 6. Obviously, this has sparked other opportunities that are under application validation across the mining sector, looking at rubbers where wear and durability are key issues, so such as conveyor belts and screens. And we're looking for increased cut and tear resistance, reduced abrasion loss, and increased fire retardance. The last example shown on this slide is rubber recycling or rubber upcycling. And what we're seeing is that if graphene is incorporated into upcycled rubber products, it can increase the strength and improve the incorporation of the recycled rubber into the product. The example shown here is with a UK-based company called Space Blue, and they're recycling used tires into consumer goods such as space mats. But we're also seeing, and as you can probably imagine, we're also seeing multiple adjacent opportunities in this sector. So the next sector is composites and plastics. Here again, the Puregraph advantage is supply and quality, but in composites and plastics, we're seeing increased strength, increased durability, and improved barrier performance. So water, chemical, and gas barrier performance. The Puregraph materials are very easy to disperse into resins and to plastics. Some recent work that we just published an update on from the University of Warwick in the UK shows that the Puregraph materials are readily incorporated into thermoplastic matrices through normal extrusion processes. We can make very high concentrations, so 30% by weight concentration master batches, and plastic master batches are now available from First Graphene. So if you have an interest in plastic master batches with graphene, please contact us. Some of the sectors in composites where we're very active are marine and leisure items such as swimming pools. So those are the images at the top right. And the figure on here is the improvements in performance of a composite, which is a swimming pool wall. And you can see from the chart that the gray bars in the histogram, they're the flexural strength that is required to comply with the standards in US and UK and then Australia. The standard laminate, the standard composite is the red bar, You can see that easily meets the standards, but by adding graphene, we get an immediate 30% improvement in strength, which is the green bar. So this enables the use of less materials and lightweighting in all of these systems. So to look at some specifics, so the company Aquatic Leisure Technologies is the largest swimming pool manufacturer in Australia. And they, last week, announced launch of a product range based on graphene materials. So the product range was launched in May. It's branded Graphene Nanotech products, and this will be incorporated across their entire pool product lines. And what they've reported in these products is 30% increase in flexural strength, which enables a 30% lightweighting and improved water resistance, so improved resilience to water from the backside of the pool. Also in marine, we've got multiple opportunities in marine. The one we are able to talk about is with Ascent Shipwrights, who are a sales client based in Western Australia. They have made a graphene boat. And if you visit our Twitter account, you'll be able to see a video of this being assembled, which is quite interesting. They're looking at increased flexural strength, increased stiffness, again, of course, improved water resilience, water resistance. We're also seeing, we're again seeing multiple adjacent opportunities in this market. So you may also have seen on Twitter the graphene enhanced surfboards, for example. So multiple opportunities in this marine sector. Lastly on here is a thermoplastic application with a company called Hexcel. Hexcel manufacture large-scale oyster baskets manufactured from high-density polyethylene. And by adding PureGraph to the high-density polyethylene, we can increase yield strength and the abrasion resistance. And obviously, the target here is longevity and durability. And Hexcel are a current sales client. Cement and concrete. Now, as Terence said, I've been involved in graphene for a long while. And when people 10 years ago started to talk about putting graphene into cement and concrete, this seemed kind of improbable. But we're seeing real opportunities here because the effect of adding graphene is effective at such low dopant levels. So if we look at the concrete industry in terms of the big picture, it's an immense industry. After water, concrete is the most widely used material in the world. And the use of cement-based concrete contributes somewhere between 6 and 8% of global carbon dioxide emissions. So potentially increasing the strength of these materials by, say, 30%, you have the opportunity to reduce the amount of cement and concrete which is deployed, and therefore reduce the carbon dioxide contribution of the cement. So what's the PureGraph advantage in cement and concrete? Well, again, supply and quality. Supply will be everything in this opportunity. Being able to scale and supply in the thousands of tons is essential to provide a concrete additive to this industry. What we've shown to date, and we've got 3 peer-reviewed publications using PureGraph materials, and those publications all show that by adding small amounts of PureGraph, we get a 34% improvement in compressive strength, 27% improvement in tensile strength. The nice thing about having the peer-reviewed publications is through that work, we also know the mechanism. And how graphene strengthens concrete is by the barrier effect of the high aspect platelets, which control the hydration of the portlandesite crystallites. And effectively, you get larger crystallites, which strengthens the concrete. So this is a completely different mechanism to reinforcing a polymer. We've also shown that by adding graphene, it enables the use of lower cost aggregates, such as using recycled concrete as an aggregate in new concrete. And by adding graphene, it raises the performance of those materials. Again, because we've got product options, we've got a range of mechanisms to add the graphene additive into the cement value chain or supply chain. That can be in powder or through an aqueous dispersion. Looking at that value chain, this is one area where adding a specialist concrete commercial manager has made a really big impact for us. And what that's done is it's enabled us to identify that there are multiple opportunities for PureGraph along the cement value chain, starting from the cement itself. So cement manufacturer, the industry is looking at many alternatives to Portland, ordinary Portland cement. So these systems that are being used typically don't perform as well. So adding performance through additives to these cement products is quite significantly important. So graphene can potentially increase the strength of these systems and also improve the integration of some of these alternative aggregates. And as I mentioned, recycled concrete is one of those. In structures, obviously by adding PureGraph into concrete systems, increasing the compressive and tensile strength can have a significant impact on how structures are developed, designed, and contracted. The addition of graphene will also improve, it will reduce water penetration and therefore improve corrosion resistance. And it's also been shown to reduce surface abrasion of these concretes. Also in prefabricated components, whether from blocks to larger items, increasing the compressive and tensile strength offers opportunities to change the way these precast items are put together. And again, you also get a reduced water permeability in these systems, which is attractive. And then once you've got the concrete component, many of these systems are actually coated or post-treated, and it's possible to enhance the coating treatment with graphene to improve water permeability and improve corrosion resistance. So we've got multiple activities across this value chain, all of these applications in validation at some stage, and really, really exciting industry to be working with. So that was a quick run through some of the examples in commercial, in the commercial sectors. We continue to look at innovative solutions, and we do listen really closely to our customers when they bring forward new problems and ideas. So we continue to develop the PureGraph range of products. And as I said earlier, the PureGraph Aqua is a product we launched earlier this year. It's a really interesting material because it's a commercially available graphene hydrogel. It contains no surfactants, so it's essentially just graphene and water. And the water molecules seem to be present as spacers between the pristine graphene platelets. And of course, what this means is when you're dispersing this into a polar or a water-based system, the separation of the platelets is more straightforward, and you get better dispersion of the individual platelets. And what this means is you have a much easier route to formulation in systems such as paints, inks, cements, and latex rubbers. And we've got multiple customers working with these PureGraph Aqua systems, and it is really interesting. The products themselves, the Acra products themselves, are available in all the same sizes that the PureGraph materials are available in. So 5, 10, 20, and 50 micron product sizes. In addition to that, we continue to look at functionalization, and our collaborators at the University of Adelaide have just published some really interesting work using PureGraph materials. And they found that the PureGraph platelet is actually an ideal precursor for these functionalization chemistries. And this is because, as I described earlier, PureGraph is a pristine graphene platelet with some oxygen functionality at the platelet edges. So it's ideal for chemistry to functionalize and make the material more compatible. So we're working with the University of Adelaide, and we've got the opportunity to make even further enhanced water-soluble materials or water-dispersible materials. But what's really interesting about these is the opportunity to make reactive functionalities. So we can actually have graphenes that participate in the curing reactions of rubber systems, for example. So a really, really interesting development. And we continue to look at energy storage materials. Our focus here is on the emerging supercapacitor market. And we have a really nice set of materials, which are metal oxide decorated graphenes. The technology was developed at the University of Manchester by Professors Kinloch and Professor Drive. And excuse me. And what these materials are, they're graphene scaffolds. So if you look at the top center image on the right, these are almost honeycomb graphene scaffolds with nano-sized metal oxides deposited onto those surfaces. So they're ideal materials, ideal substrates for pseudocapacitance. And what we're seeing with these materials is we do get very high capacitance per area. We've shown that we can scale them. The manufacturing process is very similar to our existing electrochemical exfoliation. And we continue to work at these both in our labs in Manchester, but also we're doing further testing with the Warwick Manufacturing Group at the University of Warwick. And what's interesting is these same materials, which we've learned how to scale, they're very effective catalysts in hydrogen fuel cells. So they work very well as oxygen reduction for oxygen reduction reactions in polymer fuel cells. So they're potentially a replacement or part replacement for platinum catalysts in these devices. So this work was done at the Manchester Metropolitan University, and we've just received some UK government support to continue evaluating and developing these materials with the Manchester Fuel Cell Innovation Centre. So that work is just underway, and we're expecting some really interesting results over the next few months. The final slide today on the innovative solutions is something which is unique and disruptive. So this is a technology that was developed by a UK-based inventor and is exclusively licensed to First Graphene. And essentially, it's a one-step process to convert oil fractions, so petroleum fractions, directly into graphite and graphene materials. So the image that's at the top right of this slide, showing the water white vial being converted into a black dispersion, is exactly what happens. You start with a water white oil fraction, and running it through the process, it's a one-step process. You get immediate conversion into graphene and graphite materials. There is obviously chemistry going on here, and the chemistry, the byproduct from the chemistry is hydrogen, which is really interesting. So it's a hydrogen byproduct. There is no associated generation of carbon dioxide with this hydrogen. So it's a sustainable route to hydrogen, ironically from a hydrocarbon feedstock. The resultant graphite, and the bottom image here shows you the high level of crystallinity that's possible in these graphite materials. Obviously, the metal contaminants are present in oil feedstocks are either low or easy to control. So this is a route to very high purity graphites. And we're currently testing these in coin cells as lithium ion battery anode materials and anode material additives. What's really interesting about this technology is it's an entry opportunity for oil suppliers. So oil-rich companies and oil-rich regions to participate in the battery materials supply chain. So we're currently engaging with several oil supply companies, and we're actively seeking relationships to try and understand where this would fit into the oil supply chain. And it's a really, really interesting opportunity at this time when the world is looking for graphite materials and hydrogen. So the final slide is just a quick run through progress that First Graphene has made as an organization in 2021. So since Michael Bell has joined us as our new CEO, we've obviously put a lot of pressure on ourselves to grow the commercial side of our business, and we're starting to see multiple relationships and multiple activities developing through 2021. And each one of these is described in more detail as a press release on our website if you're interested in looking at these individually. But I will quickly run through these just on the timeline. So in February, we announced that we'd extend our relationship with Planatech. Planatech were manufacturing graphene-enhanced face masks using PureGraph, and they're now looking at a range of graphene-coated fabrics. Early in March, the report on the wear liner from the mining trial was reported, the 6 times increase, and that has since been validated by an independent auditor. Later in March, we announced a non-binding MOU with Gerdau in Brazil, and this was towards agreeing a distribution agreement with Gerdau to distribute PureGraph and graphene products in the Americas. Later in March, we launched the PureGraph Aqua product line, which was rapidly followed in early April by the larger platelet size PureGraph 50. And then in April, the patent was granted on the petroleum to graphite process that I just described. In early May, we had some really nice results. We have a collaboration with Professor Tony McNally at the University of Warwick, and he's working with PureGraph as an additive in thermoplastics, and he's reported that it's an excellent additive for thermoplastics, it's very easy to use, and that we can get these very high master batch concentrations, and that was shown, that was reported in May. And then shortly after, we reported the collaboration with Manchester Metropolitan, where they showed that the metal oxide decorated graphenes are effective catalysts in low-cost hydrogen fuel cells. And then later in May, we were successful in obtaining an institutional placement to underwrite the further growth of the business. And right now, we're actively involved in application development with customers, developing our commercial strategy across multiple regions, looking at distribution and how we're going to grow the First Graphene business, sales and commercial infrastructure. And I would say these are the achievements in Q1 and early Q2. So we're looking forward to the rest of 2021. We've got lots of things in the pipeline, and they will be announced as they are achieved and delivered. So watch this space.
Well,
moving on, I now, of course, have to show the disclaimer slide, which you are all free to read later on this evening. And now, just to finish on contacts. If you have any direct questions, feel free to contact us. My email is shown on this slide. Telephone numbers on this slide. So we look forward to talking to you. And I will now hand back to Terence, and Terence will walk us through the Q&A session.
Well, Andy, thank you so much. Where to start? It's extremely exciting to see all the progress you made, and especially when you condense it into just what's happened in the first 6 months of this year, especially following the global lockdowns with COVID. It hasn't really seemed to slow you guys down at all. And it's really exciting to see the different application areas that you're focused on. So I want to point out one thing. You mentioned, and there was a question here about the load factor of graphene in cement and concrete products. And I just want to point out, if it's not obvious to everyone, what was listed was 0.01% by weight addition. And then you also mentioned, a capacity or inventory that you have of about 100 metric tons of the PureGraph material. That 100 metric tons, if it were just used in cement and concrete, could be used in 1 million tons of concrete at that load factor. So that kind of puts you in perspective. A little bit of graphene goes an awfully long way. The other observation I just want to make, Andy, is a lot of graphene companies, because there's so many opportunities, they have a hard time to focus. And it seems like you've really managed as First Graphene to kind of focus in on these 5 extremely interesting areas of rubber and elastomers, composites and plastics, cement, coatings, and energy storage, which, by the way, from our survey at the end of 2020 was identified as, these are 5 of the most promising areas for graphene for the industry writ large. So I think you guys are, really, really well focused. Talk to me, the rubber and elastics, or elastomers rather, and the wear liners that you guys had with the bucket liners for the mining industry. Are you able to disclose something on like load factors or approximate load factors to give everybody an idea? With many of these applications, you're really not using a whole lot of graphene in the host material. Can you talk about that at all, or is that proprietary?
No, we talk about it in general terms for sure. So the load factor really depends on what you're trying to deliver. And as you mentioned, in cement and concrete, it's very low. But then again, by the way, you said that would work for 1 million tons of concrete. 1 million tons of concrete in the concrete industry is really a tiny percent of the concrete industry. But if you look at rubbers and elastomers, it really depends on what you're trying to achieve. So typically for reinforcement, and it's different between different rubber systems, but reinforcement typically occurs between about 0.1% loading and 1%. And there's often a sweet spot which you have to identify. If you're looking at thermal and electrical conductivity, you have to go much higher. And again, it depends on the rubber system, but probably more than 5% to get really high conductivity. For electrostatic dissipation, it's less. So it does really depend on the application.
Yeah, no, I could see that. And we've seen that in general with other applications. Again, for the audience, for those people who are very experienced with graphene, you already know this, but graphene, it seems like when you're not getting the results you want, you use less of it rather than more, which is quite interesting. But I think that goes into the whole economics of using graphene. And I don't know how to wrap this question into to put it into the correct perspective. But again, on the rubber and elastomers, when you looked at the wear liners, the idea was to make a product that was more robust, but you found out it also made them more fire retardant, which was a big advantage in the mining industry, not to set equipment on fire, right? When you're turning,
yes,
this. Can you just talk a little bit about maybe some of the other epiphanies or unexpected positive consequences you've seen of adding graphene? Because it almost seems like, it's often added for a particular property like strength or barrier properties, but then it ends up, for example, in the cement and concrete, it definitely adds strength, it adds compressive strength, and adds flexural strength, but it also seems to really accelerate the cure rate, right? Which from an economics point of view on a job site is quite important. If you could get to strength in a much shorter period of time, that has some economic benefits as well. Can you talk a little bit about this when you're working with customers about it's not just the most obvious attributes that you get benefit from, but there's some tangential business case attributes to using graphene? It's a very broad question, but I know there's many examples of this.
There's multiple examples of that, Terence. And if you look at if you look at the composite pool example, we started off totally focused on flexural strength, and then in looking at some of the challenges they have in the industry, some of the bigger challenges are around the water resilience. And that's true of all glass fiber composites. And actually, we went back and found some 1950 publications, I think by Union Carbide, that described the penetration of water through glass fiber composites. And we actually repeated some of that work with and without graphene. And that's, if you look at the case, there's a case study on our website on the glass fiber composites. And the graph from there is a direct copy of something from the 1950s, which we weren't looking for when we started the work. So that's just one example. I'd also cite what I mentioned about plastics extrusion. So, plastics is it isn't just about, having the plastic pellets, the extruder, and throwing the graphene in and getting results. You need to do the work. And this is why application development is so important. But one of the benefits we've seen with PureGraph as an additive in plastics extrusion is actually it makes the extruders work better. It actually improves the way the extrusion of the carbon material into the plastic works. And that's quite a significant benefit in that industry, which, we didn't know about, we didn't look for, but it's very clearly there. So there's multiple examples of those sort of side benefits, which can actually become, as important or more important for some industries.
Absolutely. There are just so many examples of it. There was a conversation I had just yesterday, regarding cement and concrete, and from a cement producer. And once a cement producer is at full capacity, there's only so much they can do. So if you can reduce the cement capacity in concrete, they can actually produce more concrete with the same facilities, right? So you can extend capacity. That has tremendous economic benefit. So talk to me a little bit about how you guys address some of the questions. Graphene has had, for good or for ill, this kind of reputation as being a very quote unquote expensive material. But then when you look at how little of it you use, and then you look at the fact that I think in almost all the processes that you shared with us, where you're getting actual sales and you're getting proven applications, many times graphene is a drop-in kind of additive. In other words, the customer doesn't have to have a different process step. They don't have to have additional capital equipment. It basically enhances existing processes and materials. How do you address the question where people say, well, I just don't want to look at graphene, it's just too expensive, and I'm in a very cost or price sensitive commodities type industry like cement and concrete? How do you address that issue?
Yeah, so there's going to be a range of, within our PureGraph graphene range, there's going to be a range of product types. And what we anticipate in cement and concrete is we'll have a cement grade. And the cement grade will optimize what you need in there, which is barrier properties. And we'll look at, apart from that, how sophisticated does it have to be effective in cement? So the grade you're going to use for cement is probably going to be a completely different grade from the grade you'd use for, a high performing EMI shielding coating application, which has got to be, well formulated into an ink or into a coating. So I would expect, like every other industry, graphene will have these multiple grades of products, which are specifically geared towards different sectors. And I can see there's a question on what is the grade of graphene we can add in concrete. Well, most of the grades of PureGraph will work, and we're just looking at ways of really enhancing dispersion and performance into concrete systems. So all of that, graphene's still pretty much a young industry. So all of that that's got to be understood and developed. And the only way a company like First Graphene can understand and develop those products is by working closely with downstream customers. And that's why our emphasis on these commercial infrastructure and actually getting out and working directly with customers is so important if we're going to really understand these application needs.
Yeah, I would echo that. I think it's really important for customers to find companies that have the kind of competencies that a company like First Graphene has, because as you said, you can't just, hand somebody a bucket of graphene and wish them good luck. There is a bit of handling, and dispersion in particular is one of those parts of using graphene that are critical to its effectiveness. We have a couple of questions that are more on the technical side, one of which is going to relate to standards and also with the regulatory side. So I want to ask you a couple of general questions. One is, where do you see the biggest obstacle for this next step? As we're obviously entering a rapidly accelerating adoption curve for graphene, there are some regulatory hurdles such as the REACH registrations or with TSCA registration in the US. Where do you see the biggest obstacles to the next step change in commercial adoption?
Well, of course, graphene, because of its size, has to be classified as a new substance. It's really difficult to classify it as graphite because of the nanostructure. So you do have to go through product registration, and that's something that we've taken a very responsible approach to. Clearly, you can't do all of that up front in isolation from developing demand, because you've got to do the registration process hand in hand and in parallel with demand growth. So if you look at the current status of our customer base, most of our customers are in Europe and in Australia currently. So we have product registration, new substance registration in Europe at 10 tons, and now in the UK at 10 tons, thanks to Brexit. And in Australia, we have product registration at 100 tons. So we're looking at how we extend that and when we extend that. Clearly, we would expect the European one to move up to 100 tons in the near future. We're also looking at North America, and particularly the USA, which uses a very different system actually to REACH, which makes it slightly not more challenging, but it's just different. So you've got different questions to answer. Yeah. So we've taken a really responsible view to that, to make sure that we do have product registrations in place where we're selling larger quantities.
Excellent. The other question I want to ask about is on standards, and in particular, you have a lot of emphasis on your quality control approach and consistency. So if there's anything that's been one of the big challenges with graphene is consistency in batch to batch, so that what the customer gets in January is the same as what the customer gets in June and later in the year. Can you talk to us about some of the methods you use? So I want to try to combine a couple of things. So there are graphene standards that are currently being developed. A lot of them focus on measurement techniques, which are good for characterizing the material, but maybe not necessarily useful in a batch or a production line for quality control measures because the characterization techniques are too expensive, too slow, et cetera. How do you guys, what techniques do you use if you're able to share that, or if it's not proprietary? How do you do your quality control processes and measure the material?
Well, our approach to that is what's used in the specialty chemicals industry. So you have to separate out characterization from quality control. So for characterization, that's where the ISO methods and processes are really very focused on characterization, and that can mean using tools such as AFM, TEM, quite expensive, time-consuming techniques. So clearly, you can't sample every single batch that you manufacture and do TEM on that because you simply can't afford to do that. So what we use is we've got extensive characterization data, and that's all done with tools and techniques according to the ISO standard that was published earlier this year. And then for our quality control, we use tools such as the laser diffraction, particle size distribution measurement. And we know, multiple times people say, oh, well, that's for spherical particles. You're not supposed to use it for platelets. Yes, we know that. Thank you. But guess what? When our customers buy a powder product and they want to look at what the particle size distribution is, they're going to put it into a Malvern Mastersizer. Okay, so by doing that, we're talking the same language as our customer base, and we're also controlling the lateral size. So we tend to use industry standard tools like that for outline testing. So the critical ones are things like Raman. Every batch has Raman analysis on the batch, the Mastersizer data, and then some physical properties such as bulk density is a really good measurement. And then we can relate those back to more sophisticated methods such as TEM, AFM, and XPS, and looking at oxygen surface functionality. All of those things, but you do have to separate out characterization, which is really detailed look at the characteristics of the product on a platelet level, and the bulk properties of the product. And at the end of the day, what your customer really wants to know is they want to know that the bulk properties, what's in the bag when they buy a 50-kilo bag, they want to know that the properties in that bag are the same in October as they were in February. And all they really want to know is you've controlled this and that it's going to add value to my product. That's what they really want certainty on. And as I said in the presentation, we've got some very sophisticated customers who've probably spent a lot of time and effort characterizing different graphene materials, and they confirm to us that the PureGraph's the most consistent product that they work with.
Excellent. Well, I can't let this pass without having a look at this. It's absolutely fascinating, your mention of taking a petroleum distillate and converting that directly to a graphene graphite mixture. That's pretty earth-shattering when you really think of it. And as the Graphene Council, we're a neutral, independent trade and professional body for the industry globally, and we do see multiple production methods coming to market, including this, flash graphene from Rice University, detonation methods, biomass material, et cetera. And here's another method to produce graphene material directly from petroleum products, which, is especially as the oil and petroleum companies can see the loss of the gasoline market over the next couple of decades as everybody moves to EVs. They're very motivated to find different ways to use their raw materials. Do you see this as like a major new production method for First Graphene? Do you see it as a licensing opportunity? I mean, how are you looking at this truly groundbreaking innovation?
Well, I think the key point here is this is a very early stage innovation, and we're very aware of that. And but what it does is it starts from aromatic components in the oil fraction. So you're basically bonding aromatic rings together. So you're starting with, 2 or 3 aromatic rings and building them out, I don't know, to tens or to hundreds to thousands to make graphene, and then ultimately a graphite platelet. The thing, I have to say, the thing that astonished us the most is how thick the graphite platelets are that you can manufacture, and how pristine and how crystalline they are when you describe that process. So the key is really looking at the availability of these oil fractions and yields and throughputs on a scale system. And if those are favorable, then this is a genuine way to make graphene materials, to make functionalized graphene materials, because you can do chemical functionalization directly in the same process. High purity graphite materials. So effectively it's an alternative route to synthetic graphite rather than mined graphite, natural graphite. So we think it's really interesting, it's potentially very disruptive, but it's very early days. And that's why interaction with the oil supply companies is so important, because we need to understand how it would fit into the oil supply chain, really, to be able to answer some of those questions. But I agree, it's a very interesting, disruptive process.
Excellent. Well, I think, Andy, we're past the 1 hour mark. We could talk all day. I know that we have a number of questions and folks that would like to hear from you directly. So we're going to follow up in writing with some of the questions we're not able to get to this way. But I think, to summarize, the presentation you gave, to me, clearly demonstrates the versatility of graphene. It demonstrates the importance of having somebody with the kind of skill set that your team has, referring to graphene as a specialty chemical, I think is an appropriate way to look at it, because it's a special additive that gets used and enhances these other materials. I didn't know, did you see any burning questions you want to try to address before we sign off?
Oh, I was just having a look at that, actually. I think I addressed the one about reach. I think we've addressed is that we manufacture in Australia. Our early customers are all in Australia, and we've got registration at 100 tons per year in Australia. Yeah. We've got registration at 10 tons per year in Europe and the UK, and we are looking actively at the USA as well. So we're very aware of the responsibilities as a specialty chemical company. I do want to emphasize that, and that we don't treat that lightly.
Right. No, I think that's really important. And for the audience to know as well, the Graphene Council is involved directly with EPA, FDA, in discussing with them or TSCA registration and how to evolve this. I also want to comment on the company strategy, focusing on the 5 areas that you mentioned. If that was all you did for the next decade, those markets alone are enormous. I mean, we've calculated that just the anode market for electric vehicles is between 87,000 and over 1 million metric tons of graphene needed per annum, assuming 90 million passenger vehicles are produced annually. And that's just that one market. Then you go to coatings, the cement and concrete markets are similar, et cetera. So, I see this next stage, especially now that you have customers who are actually getting commercial advantage, is the adoption curve, is how do we educate other companies, consumers in these different vertical markets. We know graphene works. We know you can produce it at scale. Now the next question is just moving the needle and having adoption come, especially when you can get uplifts in performance in the 30% plus range. That's significant in any industry. So, I think you guys are really well positioned.
Yeah, and if you look historically at specialty chemicals, I mean, I worked for Dow Corning, which specialized in silicone and silicon chemicals, which is now, I think it's probably $10 or $12 billion business. And if you look at the steps that industry went through, the initial manufacturing route to silicone materials and the initial silicone products were really the manufacturing route was really not easy to do. It's very expensive. The materials weren't great. Now they're making, millions of tons of this fantastic quality polydimethyl siloxane using a completely different manufacturing route. And I think graphene will ultimately follow that course, providing that we can grow the demand. So that's why the focus on the demand side and application development at this moment is very, very important. And that's very much our focus today.
Yeah. Well, the environmental factors I think are good. And what I mean is, the focus on reduced carbon emissions, that bodes well for graphene. The increased focus on longevity of materials to take them out of the waste stream or to repurpose recycled materials, which graphene also enhances with plastics, cement, and other materials. So if you look at all those things, I think graphene lines up really well with national priorities and economic priorities for many businesses across the scope. Andy, I want to thank you. I've enjoyed, knowing you and learning from you for many years now in this graphene space, and it's just fantastic to see the progress that you and the company are making, and we're glad to have you as a member of the Graphene Council. If anybody's interested in learning more about graphene and the materials or any of the presentation that was given today, you'll receive a copy of the slides, and it'll have Andy's contact details there. If you'd like to receive assistance or information from the Graphene Council, please get in touch with us. As I mentioned, we connect 30,000 material scientists worldwide. We're active members also at the Graphene Engineering Innovation Center in Manchester as Tier 2 members. We also work with the Graph Institute in Sao Paulo, Brazil. And so we have quite a big global network where we can help connect the dots for you when it comes to how to use and take advantage of graphene. So with that, Andy, thank you so much for your time and sharing your expertise with us. Really appreciate it.
Okay, thank you, Terence, and thank you to everyone for staying with us for more than an hour. So thank you very much.
Excellent. Take care. Be safe.
Thank you. Thanks. Bye-bye.